Okay, so we'll first we'll assume that for now that the highest power in the numerator is lesser than highest power in the denominator. Okay, now the denominator is a polynomial, right? If it is a polynomial, ideally we should be able to express this in terms of some factors, right? If you are given a polynomial of let's say degree 3, then ideally you should be able to express as some x minus alpha into x minus beta into x minus gamma, right? If there are three real factors. Okay. Or otherwise, you will be able to express this as x minus alpha into some quadratic, some ax square plus some bx plus c. Right. If there are three real solutions, you will be able to express this as all three differently. Or otherwise, at least one real solution and remaining is quadratic. Agree? Agree, Amma? Any polynomial, let's say there is a 5-degree polynomial. Either you will have 5 real roots, right? A 5-degree polynomial, if it is a 5-degree polynomial, how many real roots it can have? It can have all 5 real roots, right? Or it can have 3 real and 2 imaginary, right? Or 1 real and 2 imaginary, right? Because imaginary will always come in pairs. You know this, right now? You cannot have one imaginary and 4 real. Agree, Emma?
Agreed, sir.
Okay. If the polynomial is of 6 degree, you can have either, if it is of 6 degree, what are the cases that we can get? Either all imaginary, right? Or 2 real plus 4 imaginary, or 4 real plus 2 imaginary, or 6 real. Only these cases are possible, right? Agree?
Sir, why should the imaginary only be in even number?
Because imaginary comes in pairs, right? For example, 2 plus 3i and 2 minus 3i will come in a pair. Conjugates. Right now? So, okay, try for a quadratic equation, try one real and one imaginary root. Tell me one quadratic equation where you will get one real root and one imaginary root. For a quadratic equation, what are the roots we will get? Minus b plus or minus under root b square minus 4ac by 2a, right? Right. If this is less than 0, then both roots are imaginary, right? Minus, so it will get something like minus 2 plus or minus 4i or something, right?
Yeah.
If this is greater than 0, then both roots are real, right? There cannot be a case where one root is real, one is imaginary, right?
Yeah.
Okay, no? So it always happens like this. Imaginary roots always come in pairs. So you cannot have odd number of imaginary roots. Okay? Whatever is the polynomial. Okay, ma?
Okay, sir.
This part is clear, no? Okay. Now let's say you have 4 real roots. All 4 could be different, or 2 of them could be same, 3 of them could be same. These kind of combinations, right? All 4 could be same, 3 could be same, or 2 could be same, another 2 could be different, or 2 could be same, another 2 could be same, like this. We have various possibilities, right? When you have real roots, right now? Okay. So now what we'll do is, let's say that there is a polynomial. Okay. There's a polynomial in the denominator. We are able to break that polynomial. We are able to break that polynomial in this format, right? The format is x minus r square, right? X minus r whole cube, whatever. Okay.
Okay, sir.
Wait. So let's say there is a polynomial, right? Polynomial of, let's say, n roots. Okay, you can break this as x minus alpha whole power, let's say, whole power p1, right? Or let's make it whole power l, x minus beta into whole power m, x minus gamma into whole power n, something like this. Okay, what this l, if there is the root is not repeating, this l will be 1. if the root is repeating 4 times, this L would be 4, right? So for example,
Yeah.
okay, so for example, x minus 2 into x minus 3, right? This means L is 1, M is 1. Or it could be something like this. That means L is 2, M is 1, right? Right. So, first we take whichever polynomial, we take the denominator. We'll assume that it's a proper fraction and we take the denominator. And we assume that denominator can be broken, and we know that this denominator can always be broken into some factors, right? Either these factors are linear factors, in the sense the roots are real, we should be able to break that into linear factors, or if they are not real, we should be able to break them into complex quadratic factors. Understood? Is this one clear?
Yes, sir.
Yes, sir.
Okay,
Yes,
so
sir.
for example, we have something like ax power 4 plus bx cube plus cx square plus dx plus e. Okay, if all 4 roots are real, then we'll get something like x minus alpha into x minus beta if all 4 roots are different. Okay, x minus whatever. Okay, agreed. If 2 roots are real, then you will get one quadratic equation like this: x square plus px plus q with complex roots, and remaining two are real, x minus alpha into x minus beta, right? If both two pairs are imaginary, you will get something like that: x square plus px plus q and x square plus, let's say, fx plus e, whatever. Okay, ma? Anything you can actually break down into either the highest power, either into quadratic into some linears or quadratic into quadratics. Understood?
Yes, sir.
Okay. You can always break any polynomial like this. Either any polynomial you will break into multiple quadratics or multiple quadratics and multiple linears. Okay. So you will never need x power cube, x power 3, right? Because x power 3, you can always break this as x minus alpha into something, some quadratic. Understood? This part is
Hmm.
clear, ma?
Yes, sir.
Okay. Now, this one, whenever this is a proper fraction, right? Whenever we get something like this, the theory is actually we should be able to express this in the terms of a by x minus alpha plus b by x minus beta. Okay, because denominator has got two real roots, has different roots. That's why we can be able to express this in like this. Okay,
Okay,
so
sir.
here also denominator has got two different real roots. That's why we should be able to express this in terms of a by x plus 2 and b by 2x plus 1. Okay, the roots are real and
Okay,
roots are
sir.
different and they are not repeating. Okay, so this one, what we will do, we'll assume that this can be broken like this can be broken like this, and then a into x minus 1 plus b into x plus 2 should become 5x plus 1, right? That means
Yes.
if you take the coefficients of x, what is that? A plus b should be equal to 5 and minus a plus 2b should be equals to 1, right? A plus b equals to 5 and minus a plus 2b should be equals to 1, right?
Hmm.
Right. You can solve both
Yeah.
the equations and figure out what exactly is a, what exactly is b, right?
Yes.
That is one option. Or otherwise, there is this 5x plus 1, a into x minus 1 plus b into x plus 2 should be equal to 5x plus 1. Right. We substitute x equals to 1 and this part will become 0. Then 3b should be equal to 5 plus 1, 6. Right. And we substitute x equals to minus 2, this part will become 0. Right. And you will figure out what is a. Understood?
Yes, sir.
Agreed, Amma? So this one also similarly. We break this in the form of a by x plus b and b by 5x plus b by 2x plus 1. We are ignoring this 5 because this 5 is immaterial. We can put this 5 towards the end. Okay? Understood?
Hmm. Yes, sir.
Put the card there, sir. Last one, huh? Okay, Amma? So a into 2x plus 1 plus b into x plus 2 should be equal to 2x plus 3. You substitute x equals to minus half and x equals to minus 2, you will figure out what is A, what is B. Understood? So this
Yes,
one we
sir.
are able to break this. Now, this integration is pretty straightforward, right? 1 by 3 ln x plus 2 and 4 by 3 ln 2x plus 2, whatever. Right now?
Yeah.
Okay. Now, see here. Here again, this is a proper fraction, right?
Hmm.
And here denominator again, we can break this into linear factors. Again, so we can write this 13x plus 3. This one we can write it as a by this one plus b by this one. Again, you compare and figure out what is a, what is b. Right?
Yes, sir.
Okay. Now here, there are three factors. Okay. But there are three factors, but all are same. Okay. So we cannot write it as a
Okay,
by
sir.
x minus 3 plus b by x minus 3 plus c by x minus 3. Then that means it's actually the same thing, right?
Yeah.
You cannot write a by x minus 3 plus b by x minus 3 plus c by x minus 3, no? Then it's actually equivalent to calling it as a plus b plus c by x minus 3. Okay. Now, then this theorem is actually helpful. Please read this theorem. X minus r is a linear factor of g of x. First, we assume that g of x can be broken into multiple factors. Okay? Of which x minus
Hmm.
r is one of those factors. Okay? And
Okay,
x
sir.
minus r power m is the highest power of x minus r that divides g of x. Okay? So, for example,
Hmm.
g of x has got, let's say, x minus 2 whole power 3. Okay?
Yeah.
Then, what we'll write to this factor for this x minus 2, we'll assume the sum to the m partial fractions as, we'll write this as some a by x minus 2 plus b by x minus 2 whole square plus c by
Plus
x
c by
minus
x minus 2 whole
2
cube.
whole cube. Okay? We'll write like this. Okay, this part is clear now. Let's say, what does that mean? X minus 2 into x minus 3 whole square. What does it mean? X minus 2 highest power is 1. So you'll get it as a by x minus 2 only, right? Because only this part
Hmm.
is valid. For this, what you will
Yeah.
get? How many terms you will get? You will get a some b
b
by
by
x minus 3
x minus 3 and then c
plus
by
c
x
by
minus 3
x
whole
minus
square.
3 whole square. Understood now? Okay, first what we do, we assume g of x. Okay, g of x when it is broken down into linear factors or quadratic factors, whatever. For every linear factor, this theorem will apply. Okay, if the power is 1, then you will just put it as x minus 2. So in this case, what does it mean? X plus 2, the power is 1. So that's why only this. X minus 1, the power is only 1. That's why only this. Okay, in this case, the power is 3. Right. So that's why x minus 3 square, x minus 3 cube. Okay. If there was
Okay, sir.
some, if there was some x minus 2 here, then we would have got some d by x minus 2. Okay, ma? This part is clear now?
Yeah.
Okay.
Yes, sir.
Now the same procedure continues. A into x minus 3 whole square plus b into x minus 3 plus c. Okay? Okay.
Okay, sir.
Now please be careful. The earlier method that we substituted x equals to 1, x equals to 2 and all, that will not work here. Here you have to compare coefficients and solve equations. Okay? Earlier one works.
Okay.
Okay, please remember. Here, earlier one, what we did, we substituted x equals to 1, x equals to minus 2 and all. No? This will work only in case of linear these things, and all roots are different. It will not work in the cases where roots are repeating. Okay, please remember this.
Okay, sir.
Okay,
So in that time we should compare the things.
that time, otherwise, this is the easy method. Okay, that is the original method. This is an easy trick.
Yes, sir.
This
This is for only linear, and then that
this is
for
only for
anything.
linear, and this is only for when the roots are different. So this method is called Heavystone cover-up method. Okay, this cover-up method is only helpful when the roots are different and roots are linear. Okay, ma?
Okay, sir.
Okay. So roots are different, roots are linear. So here we are covering x minus 1 and continuing with this one. Okay. Here what exactly we are doing? Here we are covering x minus 1. And when x equals to 1, we are evaluating this function. And similarly, when we are covering x plus 2 and x equals to minus 2, we are evaluating this one. Okay. This is called cover-up
Okay, sir.
method. Okay. But this is applicable only in cases when the factors are linear. Okay. And factors are different. So here in this case, you have to do the complete solution. Okay. Now in this case,
Okay, sir.
what do we get? Here, the numerator power is 2, denominator power is 3, right? So 2x
Yes,
plus
sir.
3, and x plus 3 and x plus 3 whole square. Understood? Again, you will compare coefficients. Compare coefficients and calculate and you will get this. Okay?
Okay, sir.
Compare coefficients, calculate, you will get this. See here. X minus 1, x minus 1 square and x minus 2. Okay?
Okay, sir.
Agreed? Compare coefficients and you solve. This one, see, x cube. What does it mean? X minus 0 cube. Okay? So that's why x square, x cube, and x plus 2. Understood now?
Yes, sir.
Clear now?
Clear, sir.
Okay. Now, another interesting thing. Okay. This is when the coefficients are linear. Now, let us look at the second case. Okay. Any polynomial, we discussed that it can be expressed as linear product of linear factors or product of quadratic factors. Because product of cubic factors is not needed, because any cubic, you can actually write it as some linear into some quadratic. Right? Any cubic will always have at least one real solution. That means at least one real factor, linear factor. Understood now? Any cubic.
Yes, sir.
Any cubic will have at least one real solution. That means we can always write it as x minus alpha into something. Okay? So that's why there is no way any polynomial you can have factors, irreducible factors, which are beyond x square. Okay? Quadratic are the biggest ones that are possible. Okay?
Yes, sir.
Okay, because complex roots, they come in pairs. Pair means one quadratic. Okay. Now, whenever you are getting this kind of two complex roots. Okay, it is irreducible. What does that mean? This one will have complex roots. If it is reducible, it would have come something like this: x minus alpha into x minus beta. Now that it has got complex roots, we have to leave it like this. Okay. Then what will happen for each of this one? Okay. And this one also can come in multiple times. For example, for each of this one, what we do? We write it as b1x plus c1. And same thing, right? By this square, by this cube, whatever. So for example, you have x square plus 1, x square plus x plus 1. Okay? What does this mean? You will write this as, you have something by this thing. You will write this as ax plus b by x square plus x plus 1. Understood?
Hmm.
So for example, you have something by x minus 2 into x square plus x plus 1. So you'll write it as by x minus 2. Understood now?
Yes, sir.
Yes, sir.
Okay. Now let's say you have this square. What does that mean? One more factor you will add, plus bx plus e by x square plus x plus 1. This one
Whole
also
square.
square. This one also square. Right now? Same what we have done for linear, we will do for quadratic also. But linear, it was only ABC. For each quadratic, it is ax plus b kind of format. Okay?
Okay, sir.
Okay. So this is how you will break quadratic. Now this one we have done. See. This one also we have done, no?
Yes, sir.
So this one is also linear only. X plus 1, x minus 1, x minus 1 whole square. Okay. Now see this one. 2x square plus 1. This is a cubic equation. Right? X cube minus 1. But x cube minus 1, you can always break it as x minus 1 into x square plus x plus 1. Right? Now what does this mean? This
Yes.
we will write it as a by x minus 1. Plus for this, it should be bx plus c by this thing. Okay? Now again,
Okay,
you will compare coefficients a into this one plus bx plus c into this one, and you compare coefficients of this, and you will figure out what is a, what is b, what is c. Okay? See
Sir,
here.
can we do it without breaking the function denominator, like the cubic function?
I didn't understand.
Sir, can we do the sum like without breaking x cube minus 1?
No. See, why are we doing this breaking? Because this one we don't know how to integrate. No,
Yeah.
this one we know how to integrate. This one we know how to integrate. Right? That is the original idea, right?
Yeah.
Okay. And partial fractions means we want to reduce this into smaller terms. No, we want to write this as sum
Yeah.
of something plus something. That is the idea.
Yeah.
Okay.
Right, sir.
This one we cannot directly integrate, but these these are super easy to integrate, right?
Yeah.
This numerator we will write it as derivative of denominator plus some constant, right?
Yes, sir.
And this becomes very easy. Okay, ma?
Okay, sir.
Okay. Now see this one. See, this we cannot reduce it because the roots are complex, right? So that's why for this one ax plus b, for this another cx plus d. Okay. But why we are doing here?
Okay.
Because x cube is lesser than 2 plus 2, 4. Okay. So here, this one, we are actually able to write this as again to quadratic, again complex roots, right? We cannot break this
Yes, sir.
further because these are again complex roots only. That's why this one we are writing as some ax plus b by this plus cx plus d by this. Again, compare coefficients and figure out. Okay, ma?
Okay, sir.
Now here, x square plus 1, you cannot break it further. What do you do? X square plus 1, x square plus 1 whole square, x square plus 1 whole cube. Understood?
Yes, sir.
Okay, this one, how will you write? 1 minus x whole square, and 1 ax plus c or cx plus d by 1 plus x square. Understood now?
Yes, sir.
Okay, this is how we
Okay,
create
sir.
partial fractions. So now this is interesting. Okay, so meanwhile, I suggest you to do one of these exercises yourself. Okay, try this one.
Sure, sir.
Try this one once. Try this one.
Sir, can you explain how you break down x raised to 4 plus x square plus 1 into that part? Like x square plus 1 the whole square minus x square. Sir,
Uma done, huh?
sir, I have a doubt.
Tell me.
Sir, can you like explain briefly how you divide x raised to 4 plus x square plus 1? The very first step, I don't get it.
This one. So,
Yes, sir.
this one is not working.
No, sir, like I'm asking how can we break it? Like simplify it, not break, simplify.
This one. Okay, okay. So this is pretty standard, no? So what does this become? This will write it as x power 4 plus 2x square minus x square plus 1, right? These three we are taking together. X square plus 1 whole square minus x square. Understood? A square plus 2ab plus b square.
Okay, sir.
Okay.
Yes, sir, now I
This
get it.
okay. This one we are writing it as this one. This is kind of a little algebra trick. Okay,
Yes,
ma?
sir.
Hmm.
Okay, sir.
But you have to do all these problems yourself once. Okay.
Yes, sir.
I'm just telling the procedure, but before next class, please do all of these problems once, including the ones that we have discussed. No integrations,
Yes, sir.
otherwise you will forget. And what is happening in school, ma?
Sir,
Sir,
integration,
partial fractions only.
we started parts. Pi parts.
Oh, this one only, partial only.
Yeah.
Yes, sir.
Okay, okay, good, good. I think they have done pretty fast only then.
Not that fast also, sir. The other classes have finished like 7.7 and all.
Which other classes?
So there are two batches, yeah. So one class will have one teacher and the second class will have another teacher. So that way.
Mm-hmm.
So and then he's like giving the formula and then using that in the question. He's not
Yes, sir.
like
He's not
deeply
explaining the
explaining the
question.
formula.
He's just like
What,
use
what?
the formula and then do it.
So
What?
you derive the formula yeah, in class. That in
Mm-hmm.
school he doesn't do. He just gives the formula in the board.
He
We
just
have
gave
to
us the
write it.
formula, sir. No derivation for it.
Oh, okay, okay. Now that is a little tricky, no? Otherwise, you'll not. Remembering formulas is actually very difficult.
Yes, sir.
There are
In
too many
school we just
formulas.
have to like learn the formula, sir.
You should learn
They
the
don't
trick.
like explain.
You should.
Yeah,
So you should not. I mean, by heart formulas. By heart formulas is fine, but you
That's
should
what.
know how to derive also.
exactly, sir. So and then he's like, maybe because of time constraint, he's doing all this.
Mm-hmm.
Because the other class is speeding, and then we're still stuck. We're lagging in school. So
But why like that? I mean, it should be the same teacher for all classes. No, not like that.
no, sir.
Okay, but how are other classes able to go fast?
So that's because their teacher is better.
Acha, that's a different teacher,
They're
right?
not like better. He
Yeah,
rushes
different teacher,
everything.
sir. Yeah, different teacher.
Sir, he rushes everything. That's the thing.
The other
He
class.
finishes like one sum in 30 seconds. So like
Mm.
that also is too bad. He goes
No,
really fast and then
but
our
See,
people
teacher
but
won't
he
goes really
understand. That
slow.
is
explains it.
also useless.
He
No.
he, he explains the sum properly, sir.
Mm-hmm.
Unlike like our teacher, yeah, he just does the answer properly and then he'll tell. But he
Oh.
explains each and every step the other teacher.
Mm-hmm.
Yes, sir. He explains, but then it's tough to catch up because of the
And
pace.
then, sir, what he does is he'll do half of the question and then he'll ask the other half to do
You do it
like by
yourself.
yourself.
Okay, okay.
Yeah. He's the HOD of maths, head of department in our school, the other
Okay,
teacher.
okay. The other one. So obviously he must be the better one
Yeah.
because he's the HOD, right?
Yes, sir.
And nobody can question him also. Whatever he does, that should be that should be
Yeah.
the final.
Yes, sir.
He tells everyone, sir.
Mm-hmm. 1 second. రాను పెట్టి ఓకే ఇందులో కూడా ఏది రాకపోతే అది రాను ఓకే ఏది రాకపోతే అది రాను పెట్టేసి వచ్చినట్లు కంటిన్యూ దట్ ఇస్ గుడ్ వచ్చిన కంటిన్యూ చేస్తే రాని రాను పెట్టు కానీ ఫస్ట్ నువ్వు ట్రై చేస్తే సొల్యూషన్ నెక్స్ట్ టైం పైన కూడా నువ్వు చేయాలి చేస్తావా చేయవా నాకు అర్థమే అవ్వలేదు పైన నేను మాత్రం కంప్లీట్ పైన ఇది గవర్నమెంట్ ఎంట్రన్స్ కదా సెవెన్ ఇది మీ ఇద్దరికి సేమ్ లెక్కలు జరిగితే భలే ఉంటుంది కదా ఒక్క లెసన్ వెనకాల ఉంటారు మాకు చేస్తుందా నెక్స్ట్ పీరియడ్ అవుతుంది సార్ మాకు అయిపోయింది కదా సో వాట్ నేను చేస్తాం కానీ చేస్తుంది అమ్మ డన్నా
Not yet, sir.
ఓకే ఓకే
I just started. I just started.
ఓకే ఓకే
ఇది అన్నారు కదా, ఇది ఇచ్చారు నాకు ఇన్విటేషన్ ఇచ్చారు కదా. న్యూస్ పేపర్ అంటే ఇక్కడ ఈవెంట్ ఉండాలి కదా, ఇది అంటే 3P1 ఇక్కడ మిగిలిన 3 ప్లేసెస్ కానీ మొత్తం నెంబర్స్ పెట్టచ్చు కదా, ఏమైనా పెట్టచ్చు కదా. 5P3 నో, ఇవి తీయాలి కదా. 1 2
ఒకటే వేస్తావు ఈ రెండిట్లో మారేస్తావు మిగతా పోస్ట్ తెచ్చి
4 పెట్టాలా.
రాసింది సార్ try to understand. This will be 3 is interesting.
లాస్ట్ కి 3 వచ్చింది.
Last 3 is spelling
కాదు. లేదు అది ఎంచుతాను. తెలీదు అక్కడ టైం టేబుల్ లో న్యూ క్లాసెస్ అని ఉంది. తెలీదు వాడ వాళ్ళకి తెచ్చారు, వాళ్ళు ఎవరు తెస్తారు. స్పెషల్ కిడ్స్ వాళ్ళు ఏం స్ట్రెస్ మంచిగా చూసుకుంటారు. ఆన్లైన్ రాసుకున్నాను. మండే ఉంటుంది మంచి. చేస్తాం లైక్ యాడ్ చేస్తే 3:30 సార్ యాడ్ చేస్తున్నాను. చదవలేదు.
చూడాలి
ఆ నెంబర్ we have to leave either 3 or 6 or not. Why? Okay.
Am I done now?
Sir, I just finished finding the values of ABCD. That
That's it.
itself took some time.
Oh, okay, that's it. No, ABCD is done, then this is done, right?
Yes, sir. Oh,
Okay,
sir,
fine.
after ABCD, we can leave it like that.
That's it. No, we just want
I thought you had to
ABCD.
integrate more.
No. For now, it is about
Only
only partial
resolve.
fractions. Okay. But you
Okay,
know how
sir.
to integrate now. Tell me, how will you integrate?
Sir, we do the usual method. 2x plus 1 equal to a into derivative denominator plus
Ah,
b.
right, right. A into derivative
That's
of
it.
denominator plus some constant, right? Very
Yeah.
good. Okay. Now that you learned this, okay, this one what will you do? A by this thing plus B by this thing plus C by this thing, right?
Yeah.
Okay, this is straightforward. Okay. Now these things you have done. I want you to try some interesting problems. Okay, this one. How will you do? Okay, now these questions are of mixed type.
Yeah.
This one, how will you do?
So we take log x is t and then 1 by
Hmm,
x dx equal
1
to
by x
dt.
dx is dt, but there is still 1 by x square, right?
Yeah.
Hmm. Okay, so if you are taking log ln x as t, okay? 1 by x
Sir, I
dx
understood what you said.
is dt, okay? But
Mm.
what is x? Okay, you can try that also. Okay, let's try. There's nothing wrong in trying now. X is e power t, right? X square is e power 2t, right? 1
Sir,
by x
where
square
did e
is
come from?
e power minus 2t, right?
Sir, how did we get t e?
X is e power t, no? Ln x is equal to t, right? X is e power
Yeah,
t
yeah.
only, no?
Okay, sir.
Okay, so 1 by x square, so what you have got? 1 by x dx dt, 1 by x square. That means e power minus 2t dt, right?
Hmm.
This was e power minus 2t by 2, right? This is
Yes, sir.
nothing but e power minus 2 into ln x, right? By 2,
Yeah.
which is nothing but e power ln x square, right?
Hmm.
By 2, is it?
Yeah.
E power minus x square by 2. No, no, something wrong happened somewhere. So can we integrate it like this? Ln x you are taking as t, 1 by x dx is dt, and 1 by x square x is e power t.
So did you miss 1 by x?
And that's what I'm thinking. What did we miss? Because the answer is not matching, no?
Yeah, yeah. Sir, I
Answer
think
is
you missed 1 by x.
1 by x we have missed.
I
1
guess,
by
sir. I'm
x.
not sure.
No, no, see. Oh, no, 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 wait. Ln x is also there, no?
Yeah, yeah.
Oh, ln x we missed, not 1 by x. So we have to do t into e power t, right? Right. Now you will
Hmm,
get.
yeah.
Okay, t e power t, you know how to do, right?
Yeah.
Okay, t e power t, what do you do? This is t, this is e power t, right?
Yeah.
Then the derivative is 1, and this is again e power
E
t,
power t itself.
and this is 0, again e power t, right? I
Hmm.
think this into this minus this into this, right?
Hmm.
Agree now?
Yeah.
T e power t minus e power t, right? Now what is t e power
Yes,
t?
yes.
T e power t is ln x and into x, right? Minus e power
Yes, sir.
t is e power ln x is x. Basically x ln x minus x, right?
Yes, sir.
Something like this, right? Somewhere this is not matching. Okay, so I think you can try this once. Okay, you can try this method and see whether you are getting this or not. Or otherwise, what this fellow has done, this fellow has done by parts.
Yes, sir.
Okay, so you can try various methods. There is nothing. If you get the answer, that is well and good. Otherwise, what he has done, he has taken by parts. By parts, which one, which side? Again, you can choose both sides, right? ln x
Hmm.
and 1 by x cube like this, or 1 by x cube and ln x, right?
So I think 1 by x cube and ln x is better.
Oh, let's try both. I think 1 by x cube, and this becomes x power minus 2, x power minus 2 by 2, right?
Yeah.
Right, no?
So divided by minus 2 here.
Hmm?
Sir, won't it be divided by minus 2? X
No, no,
raised to,
so, okay. What is the integral of x power minus 3? X power minus 3 is x power minus 2 by minus 2, right? Right.
yeah,
Right. So, this into this minus integral of this into this, right?
yes, sir.
Minus, no, minus ln x into x power minus 2 by 2
Minus
minus
2.
integral of, this minus and this will become plus integral of 1 by x into 1 by x square, right? Dx, right?
Hmm.
This
Yeah.
is nothing but 1 by x cube. This integral you can easily do, right? Again, x power minus 3. Right now,
Yeah.
x power minus 3 is again x power minus 2 by again minus 2, right?
Hmm.
Right, Nama?
Yes, sir.
I think that's what he has done. Okay?
Okay, sir.
Okay. I think we have reached this here, till here, right?
Yes, sir.
Okay, cool. This
Yes,
one,
sir.
how will you do? 1 plus x by 1 minus sin x.
Sir, we take this. Sir, it's an
Again,
identity here. Sin x equal to 1 minus cos 2x by 2.
1
No.
minus cos 2 is better, but how will it simplify? So you can have different procedures. Again, you can try something like sin x, you write it in terms of tan x by 2, right? Then
Yes, sir.
this might become a quadratic equation, right? Or this fellow has done it a different way, right? So
Sir,
what is sin x?
rationalizing.
He has done rationalizing, okay. Otherwise, you can write it as 2 tan x by 2 by 1 plus tan square, right?
Yeah.
Right. Again by 1 minus 2 tan x by 2 by 1 plus tan square, right?
Hmm.
This becomes what? 1 plus tan square x by 2 plus 2 tan x by 2 again by 1 plus tan square x by 2 minus whatever 2 tan square x by 2, right? Something like this.
Yeah.
Okay, so will this work? This might not work, no? You can try different ways.
Sir, we can.
Or
Yeah,
or
yeah,
or
yeah.
or,
It
or you
won't
can
work.
you might be able to make this work also, right? So what you will do, you will break this into two parts. 1 plus tan square x by 2 secant square x by 2 by again 1 plus tan square x by 2 minus 2 tan x by 2, right? Plus
Yeah.
again 2 tan x by 2 by 1 plus tan square x by 2 minus 2 tan x by 2, right? So this one,
Hmm.
again, it's in our familiar format, right?
Yeah.
Tan x by 2, you can take it as t, 1 plus t square minus 2t by dt. This one, secant square x by dx is dt, right? And
Yeah.
this is again 2t by 1 plus something, some quadratic, right? So this you will get, see,
Sir, but then
that's
here there is no secant square x, so how can you do it?
what now?
Sir, here
No,
there is
but
no secant square
this
x,
is
so
like linear by quadratic, no?
yeah.
It's linear by quadratic, why do you need a secant square? You don't need, no? Okay. So you're saying here there is no secant square, right? 2 tan x by
Yeah.
2 by 1 plus tan square minus tan square. Okay, good question.
Sir,
We'll go
or
and get,
else even partial fractions will work here because
no,
never
no,
mind.
partial fractions, you still need it in terms of t, right? But it is tan x by 2. We have to take some substitution, right now? Okay, or otherwise, what this fellow has done, I think this one will work. Right, this one is pretty straightforward, no?
Hmm.
what he has done, this one you understood now?
Yes, sir.
This is pretty straightforward, right? Plain
Hmm.
plain integration, this one. Just rationalization, after that it is plain integration, right?
Yes, sir.
Okay, this one. This one I think you can do with partial fractions, right? See, the numerator is of higher power. What you will do? You will do the normal division and get this in a regular partial form fraction, right? Regular proper fraction. This you can integrate. This you can
Sir,
integrate. Right?
can you explain the division once and then
A regular.
the format as well?
This is regular division, no? X power 4 divided by x square plus 1.
Yes,
Right?
sir. After division, you like arrange the terms, say
X
quotient
square,
plus
you do x
remainder,
square
like
plus
something.
1. And then, so this is x power 4 plus x square, right? This becomes
Yeah.
uh, this one. This is 0. This is minus x square, something like this, right?
Yeah.
Okay, so that's right. So what does this mean? X power 4 equals to x square plus 1 into x square minus x square, right? Something like this. So x power 4 by x square plus 1 should be equal to this by x square plus 1. Right now?
Yeah. So is it necessary to divide by x square plus 1?
What ma?
Sir,
No,
is
no,
it
or
necessary
otherwise you
to
can write
divide?
it like this. See what he is trying to say is x power 4 plus x,
Yeah,
okay,
that's
x
what, sir.
power 4 minus 1 plus 1 is doing. Okay, leave this. What he is doing is x power 4 minus 1 plus 1, okay? By x square plus 1. This becomes, I think, x square minus 1 into x square plus 1, right? Plus 1 by
Yeah.
x square plus 1, right?
Yes,
So
sir.
this becomes x square plus 1 from the left hand side and 1 by x square plus 1 on the right hand side. That's it.
Okay, sir.
Understood now?
Yes, sir.
Okay. Next, this one. This one, how you do? What you should read is,
I have one doubt in the
ah,
previous one.
ah, ah.
Sir, can you explain how you arrange the terms after dividing?
Okay, wait.
Like you multiply quotient into something and
No,
then
wait.
minus
So
the
this
remainder.
one only, no?
Yeah.
X power 4 minus 1 plus 1, okay? This is x square minus 1 into x square plus 1, right? Whole of this way x square plus 1, right?
Yeah.
And that means left hand side, this and this will get cancelled. It will be left with x square minus 1, right? Plus 1 by x square plus 1. That's it, no?
Yes, sir.
This plus this by this means this by this plus this by this. Okay, ma?
Okay, sir.
Understood, no? Okay. This
Yes, sir.
one, just tell me the idea. You should recognize some similarities, some things related in this.
So sin inverse x is t and then
Ah,
1 by
great.
root of
Very
1
good. Very
minus x
good.
square is
Very
dt.
good. Sin inverse x is t. 1 by under root 1 minus x square dx is dt. Okay?
Yes, sir.
Right.
Sir, we should first like separate the terms here 2x
Ah,
by root
excellent,
1 minus
excellent,
x square
excellent. Very
minus.
good.
Then
2x
only we
by
can do it.
under root 1 minus x square. Right? Minus under root
Yeah.
sin inverse x by, sorry, sin inverse x by under root 1 minus x square. Here, you will take this as t. So that 2x dx is dt.
Hmm.
Okay? Here you take this as t so
Hmm.
that this becomes dt. Understood now?
Hmm.
You will separate this. You will separate this one. Here you will take this as t. Here you take this as t. And then you are good to go. Understood, ma?
Yes, sir.
Cool. So, then I'll send you these slides. Okay. We'll stop here.
Okay, sir.
Next, we'll meet on Saturday, 2:30, right?
Yeah. 2:30.
Okay, ma? Shreyas, okay, no? Saturday,
Okay.
2:30.
Yes, sir. Yes.
Okay, ma.
Yeah.
Cool then. Take care. So whatever we have discussed so far, no, in this slide, please redo all of these questions. Okay.
Sure, sir.
In these slides, please redo all of these questions. Okay, ma? Cool then.
Okay, sir.
Take care.
Thank you,
Bye
sir.
bye.
Bye, sir.